Alrighty, in this video we're going to go over how to do an external flow simulation in Star CCM+. We're going to be doing it on this wing here, or you can also do this on whatever geometry you want. So we're going to take this, whatever part you have, you're going to put it in an assembly. Okay. And then once it's in the assembly, have the origin of the assembly and the origin of the part be in the same location. And then create a new part along with the geometry that you're wanting to do, and just leave it blank. Save it as your mold. And then if we go back to our assembly, what we want to do is insert components, and you want to insert the blank part that you just made. So as you can see now, our mold part is in this assembly, and its origin is also mated with the rest. So now we want to right click, edit this part, save the assembly, and we'll just go normal to this plane. So now in whichever frame is parallel with the flow direction that you're wanting to do, create a sketch. And now what you want to do is create your fluid domain for the part. So in this case, just a large rectangle. And a smart dimension. We'll go 2500 by and just create a boundary box which is suitable for the part that you're doing. Oh, I want to increase that actually. So for this wing, we don't need a whole lot of area in front of the part. However, we want a lot after to see what the flow does behind the part. So now what we want to do is extrude this box. Usually your part would be in the mid, it would all be in plane. So you would just have to do a mid-plane extrude, but in this case, since it is not, I'm just going to do a blind rough extrude. And you want to try and get it fairly even on both sides of the part. So as you can see, now we have our big box. And the next thing you want to do is under analysis preparation, select cavity. And now what you want to do is go in your list of parts and select whatever part you're trying to do the CFD on. And OK. So now, if we hide the rear wing and we change the transparency of our box, we can see we now have a perfect wing in our mold. So exit that, and now we want to go back to our individual mold part. Which is now updated with our thing, and we go File, save as copy, and what we want to do is save it as a parasolid file, and save. Now what we can do is head over to CCM. Alrighty, now that we're in CCM Plus, we want to create a new file. In this case, I'm going to do parallel on localhost, and I'm going to use 4 of my processor cores, and select OK. And now that we're all loaded up, we're going to go up to this top bar and select Import Surface Meshes. And go to wherever you saved your mold file. So here I can see mold._xt is our parasolid versus the other is a part. So I want to select the parasolid, open it. I leave all these top parts the same, but I check the parts validity, repair invalid bodies, and simplify assembly structure. And I also change the tessellation density to fine. That's just a personal preference, just to make things a little bit more accurate. So now that we have our part in Star CCM Plus, what we can do is on the side here, under geometry parts, we have our mold part and its surfaces. So what we want to do is right click, split by patch, and now we're assigning the different faces for our fluid domain. So our front face, we want to call that our inlet. The outlet at the end. And the rest of these faces, I'm just going to call surrounding. If you were, since this is a rear wing, I'm just floating it in the middle of the air. However, if you were doing like a car or something low to the ground, such as a diffuser, you would unselect this bottom face and create a different face for it. That way you can assign it to a different region. Next, what I want to do is split up each of the elements. So I'll just call it E1 for the first one, E2 for the second, and E3 for the third. And then what we can do is you can control click the different faces on the end plates. To assign those to a region as well. So this one I'll call my left end plate. And now as you can see, I actually missed one. So all I can do is just select that, call it left end plate 2, create that, and now all the faces left are just on the right end plate. Actually, I got my left and rights mixed up. Oh well. So now if we close, go back, we have all of our different surfaces. Now since I forgot one of the faces on This end plate, what I can do is select left end plate, control click the second, right click, and combine. This will just combine all those faces into one face. And then rename the other one to right end plate. So now the next step that we want to do is assign these parts to a region. So what we'll want to do is in the side menu here, select mold, right click, and we want to assign parts to regions. In this we want to create one region for each part, create a region for each part, and we want to create a boundary for each part's surface. And apply. So now if we scroll down to our regions, mold, boundaries, we can see we now have a boundary for each surface that we just made. Now our elements and our end plates, we want to keep them as walls. However, our inlet, we want to come down to the properties menu and change it to a velocity inlet. And same thing for our outlet, we want to change that to a pressure outlet. And then our surroundings, I put as a symmetry plane. So basically just a void surface per se. Next step is we want to do our meshing. So back under geometry, we want to go to operations, new mesh, and automated mesh, and select our mold part. And we want to, I always select the surface remesher, automatic surface repair, and then you can choose whichever mesher you'd like. I usually do polyhedral, however tetrahedral and trim cell would work the same. It's just different shapes of the mesh. And then I select prism layer meshing as well. And okay. So now this new node pops up for automated mesh. And we have some default controls. And the base size comes up as 1 meter. Since our part is much smaller, I'm going to do this as 25 centimeters as our base size. And I leave the rest of the base controls and execute that mesh. Now if we come up top, open a new mesh scene, we can see our mesh and we can hide the surroundings. As you can see, our mesh it's pretty bad. As you can see on the ends, our base size is very, very large. So what I'll actually do is back in our drop down menu, actually I've messed up and put it as 25 meters. Go down to 0.25 meters for our base size. And under custom controls, what I'll do is right click, new, I'm going to do a surface control. And this new node will pop up. Right click, edit. And now you have to select which part surfaces you'd like. So click the 3 dots under mold, you want element 1, element 2, element 3, and your end plates. As you can see, they're highlighted now. And then under controls, target surface size, you want to change to custom. Minimum surface size, change to custom. And then under prism layers, custom. And under customize for that, I change the number of prism layers. Then you can subtract the controls and go into values. Target surface size, I like to just change it to absolute, and I want our base size for these, our target surface size for these to be 10 centimeters. Actually, 7.5 centimeters. And then our minimum surface size will be another absolute, and we'll go 2.5 centimeters, which is the same as what it was set already. And then number of prism layers, I like to just add one, so I'll go 3. So now, if I execute our mesh again, it should come a lot nicer. So as you can see on our ends, the mesh is a lot nicer there. And if we actually come to our parts, the elements are a lot nicer as well. As you can see, the leading edge on the first element is a bit jagged. So what I can do is go again to my values under my custom controls and just decrease my target surface size to 5 centimeters. And my minimum surface size will go 2 centimeters. Now, another thing you can do to get a more refined mesh is add a volume of refinement. So what you'll want to do for that is under parts, right click the parts tab and go to new shape part and select block. So as you can see, a block will snap to the whole part. And what we want to do is just using these nodes, create a smaller box in your fluid region around whatever you're doing your analysis on. So I'll just bring that in, bring that in. And now you can see we have a small volume of refinement, and you want to press create and close. So now you can see we have this block. And now if we come to custom controls again, right click new and volumetric control. What we can do is edit that, select the parts for it and select block, which is our volume of refinement. Under controls, we can change our surface remeshing and our prism layers in that region. Now you can do this multiple times as well as do other types of custom controls such as part controls, curve controls. But for this, I'm choosing not to just because it's a fairly simple part. So now we can right click and execute our mesh again. Alright, now our mesh is finished and you can see our elements are a lot more refined now and near perfect. So we'll want to take the next steps, and under Continua on the sidebar, a physics node will have popped up, and what we want to do is right click and select models. For this, I'll make a more in-depth video on the various models that you'll want to select, but I choose steady time. Since we're doing an airflow, I'm going to select gas, a coupled flow, and a constant density, and a turbulent flow. And here you can pick whichever turbulence model you'd like. I find for wings, the Speller Almuris works very well. However, for our full FSAE car, I did have to use K omega or K epsilon to get a value to converge. And then once you select your model, close. And now you have your physics all set. What we want to do is go down to solvers, our steady solver, stopping criteria, right click, new criterion, and fix steps. Here under this node now, we can change our number of steps. We'll go 300 just for time's sake. And under here, stopping criteria, I'll change to 300 as well, just because you don't have to. It will stop at the 300, but I like to change it just for peace of mind. And after this, what we can do is go up and create a new scene and a scalar scene. And what we'll want to do is select our various surfaces of the wing and drag them into the scene. So now we have our part, and right click to select a function. I'm going to plot the pressure in this one, and I'll create another scene as well and do the same for velocity. Scene setup, under our physics node on the side, we want to set our initial conditions and our velocity. So if we look at our coordinate system, our velocity will be coming in the positive x direction. So we'll want to set that at whichever velocity you want to test at. I'll test ours at 17 meters per second. And now we should be able to run our simulation. So up top, you can initialize your solution and run. And if you go to your pressure scene, you can see the pressures plotting throughout the wing. Our simulation is done running. We can see that we have large negative pressure under our wing and a high pressure on the top. One thing that I did forget to mention while setting up our simulation was to activate the expert driver. So what you want to do is under solvers, in the coupled implicit node, go down to expert initialization and select, it'll be on none, select grid sequencing, and then under solution driver, it'll show none and select expert driver, and then select the expert driver node, and I'll post a screenshot here of some suggested values that Star CCM Plus uses for their wing simulations. and I usually change them to those. And as well for grid sequencing, I'll post a picture of suggested values for there as well. And what that'll do is just help your solution converge. If we go to a force plot that I made real quick, we can see that it's sort of all over the place at first, but then once I activated those drivers, it converged to a solution right away. This video done, you should be able to go and apply this simulation setup to various other parts you're wanting to simulate, as well as larger assemblies. I will be doing a separate video on the different types of reports and how to use them to get or to actually see the data that you're wanting to see. So that'll be all for this one.